students, I am Nilanjana Sanyal. Welcome you all to my channel in its online math classes. Our today's topic is conversion of logarithmic equations to exponential equations with variables. Now you may be thinking that we have already had one session on conversion of logarithmic equations to exponential equations. Yes, of course we did have one video session on this topic. But I am assuming my students are totally new to this chapter on logarithms, and I have seen many students who know how to convert a logarithmic equation to its corresponding exponential form when the log equation contains only numbers. But when the log equation contains some variables, they get confused. So that is why I have thought of making a separate video session on conversion of log equations to their corresponding exponential or power forms which contain variables. Okay? And you know the logarithmic form. I am writing this as BAP, base, argument and product, which means the result. And we always read from left to right, and this is exponential form, which is BPA, base, power and answer. So without any further delay, let us start with our today's session. First of all, let us look at the rules. The rules will exactly be the same as our previous session, but since there are variables, you will be seeing that the rules are exactly the same, no doubt about that. Instead of numbers, you have to write variables. And since I have written this BAP and BPA, that is why I am giving you these rules. Otherwise, it is not mandatory. Rule number 1 says keep the logarithmic function expression on the left-hand side of the equal to sign. The right-hand side will be having the product or result. Again, I am saying this is not mandatory. I am assuming my students to be complete beginners of this chapter. So, in order to maintain a general format, I am preferring to keep the log term on the left side of the equal to sign. Okay, so that we can follow this BAP. Rule number 2 says take the coefficient if not equal to 1 of the log function to the other side. We will be understanding the meaning of this rule better when we go to the questions part. Rule number 3, convert to the exponential equation using the BPA rule. And rule number 4 says do not keep a surd as the base in your final answer, which is optional. If you think you cannot convert a surd to an integer, or you are making some mistake while converting, just leave it. Leave it. You will not be losing any mark. But if in case you want to convert and you make some mistake, you are bound to lose some marks. Okay? So if you think you are making some type of mistake while converting a surd to an integer form, do not do this. But it is always better to give the final answer without a surd. Okay? So let us start with our today's questions. Question: write equivalent exponential statements for the following. Question 1. Y equal to log x to the base s. Now you see this is not 5, this is s, and here the student just gets confused. Because instead of 5, they could have converted if instead of s, they had this number 5. Why I am taking 5? Because s and 5, they look not exactly the same, but more or less the same. So, rule number 1 says we have to keep the log term on the left side. So, we will be rewriting this equation and we bring this term to the left side, or we write this first. It is log x to the base s equal to y. And this is b, the base, this is x is the argument and y is the product or result. This is BEP. We have to convert to BPA. That is base, power, P is the stands for the product and the power, base remains the base, and the argument becomes the answer. So it is BPA, which is s to the power of y equal to x. Okay. Coming to question number 2. Log s over 2 to the base. Now over here it is 5. Okay. Equal to t. Now in this case the log part is on the left hand side. We have not rearranged because we do not have to rearrange anything. And this is the base, this is the argument, and this is the product, which is the result, which will become the power. This base remains the base and the argument becomes the answer. So the exponential form will be 5 raised to the power of t equal to s over 2. Coming to the third part. Okay. We can keep it this way, but in case you don't want to keep your final answer in the form of a fraction, you can multiply the entire equation by 2 and you get this as 2 times 5 raised to the power of t equal to s. You can write this as well. This looks better, of course. Okay. Question number 3. Now over here you see, you will be understanding this meaning of this rule too. Over here you are seeing there is a coefficient of this log term which is not equal to 1. Previously the log terms had coefficients equal to 1 in the previous 2 cases. But in this question the log terms coefficient is not equal to 1. So we will be, the rule 2 is saying take the coefficient of the log function to the other side. How do we do that? We divide the entire equation by the coefficient. So if we divide the left hand side, we will be having 7 in the numerator and 7 in the denominator. So they will be cancelling each other. And on the right hand side, we will be having g over 7. Okay. So that is what I have written over here. Log q to the base m equal to g over 7. M is the base, q is the argument, which will become the answer, and g over 7, this is the product or result, which will be the power. Okay. So it is m raised to the power of g over 7 is equal to q. I think this is better instead of writing it in the form of 7th root of m to the power of g and all those stuff. I think this looks better. Okay. So it is, you keep it this way, m raised to the power of g over 7 equal to q. And if you don't understand what is 7th root and all those, just forget about what I have said just now. Okay. It is m raised to the power of g over 7 equal to q. Coming to question number 4. Log n to the base square root of k equal to r. And of course, k is definitely not equal to 0 or not equal to a negative number. I have not written them specifically, but I am saying that k is not equal to 0. K is not a negative integer or it is not a negative number. And n also, it is not equal to 0. It is not equal to any negative number. K is not equal to 1 as well. These restrictions are there, but I have not written these restrictions because I do not want to make you familiar with these restrictions right at this moment. You will be knowing gradually about what can be taken and what cannot be taken. In our future sessions, we will be taking up those restrictions. Okay. But right now, whatever is the base, whatever is the argument, and whatever is the product, you just deal with those. You don't have to be worried about what can be taken and what cannot be taken. Okay? So, square root of k is the base, n is the argument, and p is the product, which means the result. And the exponential form is the BPA rule, so it will be square root of k is the base. This p product becomes the power raised to the power of r, should be equal to, argument will become the answer, should be equal to n. So we will be having this as square root of k raised to the power of r equal to n. And now comes the rule number 4. We are having the square root as a base. So if we want to just avoid writing the square root, what we can do is, actually square root of k raised to the power of r can be written as square root of k raised to the power of r. And if we take, or if we square both the sides, we can get rid of the square root. So it will become k raised to the power of r equal to n raised to the power of 2. If you cannot write this step on your own, just forget about this step. You keep it up to this point. Okay? Do not make any mistake trying to convert it to this step. Okay? So students, this brings us to the end of this session. Please like, share and subscribe if you find this video helpful. Thank you for watching this video till the end. We meet again very soon. Till then, bye.